Hello and welcome back to another VMK in the game development series. In this VMK we're going to be implementing the material class, and by using the material class we'll be able to give color to all different kinds of objects that we create. And when I say objects, I mean anything that we've created in the past or anything that we'll be using in the future. Everything will have to be some sort of a color, whether it's gray or white or green or blue, whatever. So using this material class we'll be able to define what color it is. But materials are not restricted directly with just color. We can also control things like specularity, emissive colors, as well as a couple other attributes. We're going to implement the material class in this video, and then in the next video I'll show you how to incorporate them into our objects so that you can use them and then render things being different colors. So let's get started. Inside of our scene library here, we're going to need to create a new material.cpp and material.h file. We can do this by right-clicking on SceneLib, going Add, New Item, and we're going to create a CPP file. We'll call it Material, and repeat that for the .h file. Okay. In the .h file, we're going to define material_h at the top, and then we have our class, which just has a constructor and a destructor. It has no other public, protected, or private functions. It does, however, have a bunch of public members. There's an array of 4 floating point items for the ambient color. There's diffuse color, specular color, emissive color, shininess, and visibility, which is a Boolean value here. Let's save this and go into the material.cpp. There isn't going to be very much in here because the material class itself doesn't have to do very much processing itself. We will have to write a bunch of wrapper functions somewhere else which will be using the materials. So let's take a look at the constructor. Inside the constructor we need to initialize all of our member variables. So for the ambient color we're going to set it to be 0.2, 0.2, 0.2, and 1. Now remember, the last value here is going to be treated as the alpha value, whereas the other 3 values are going to be red, green, and blue. So by using 0.2 I'm setting it to a very kind of dim gray color. Diffuse is set to 0.8, 0.8, 0.8, and 1, and again this is also a kind of a brighter gray color, and you've seen this already because these are the same default values which I've been using in the past for all of our objects. So the sort of gray color that all of our objects are the exact same parameters here inside this material default constructor. Specular is set to 0, 0, 0, and 1, emissive 0, 0, 0, and 1, and shininess is equal to 0. And then finally visibility is set to true, so whenever we do create a material we're going to allow the object to be rendered on the screen. The destructor doesn't have to do any work because we are not using any dynamic memory. Okay, so that's the material class. Let's just compile this, make sure it looks okay. Oh, we do have an error here. Material. Oh, looks like we missed a closing statement here. Right at the very bottom, don't forget to include the end if, or else this define here won't have a closing bracket. So let's go and compile that. Okay, so that looks good now. We can close this. The other thing we need to do is inside of our scene, you'll remember that we have some functions here for handling lights, for handling textures, fonts, and our nodes. Well, now we're going to be adding the material class, which is going to contain a bunch of different materials. And we want to do something very similar to what we've done here with the geometry. We create a geometry pointer and we're going to go and save the geometry inside of our container, where it's located down here. So all of our geometry gets stored inside here, and then when we're done we call delete all geometries. We need to do the same sort of thing for the materials. So we're going to have a save material function which we're going to pass in a pointer to a material, And then we also have a delete all materials function, which is going to delete all of the materials that we save up above. The materials that get passed into the save material function are going to get stored inside of this container here. So we have MVP materials. And again, it's the exact same as before. It's just an STD vector. Okay. So I think that's about it. Let's go and implement these two functions. Let's open up scene and let's put it underneath the geometry part here. Save geometry, delete all geometry, right here. Okay. Here we have delete all materials. So again, it's exactly the same as what we've had before. We take our vector that contains all of our materials. We define an iterator and we assign the iterator to point to the very beginning of this container. We're going to iterate inside this for loop until we are not at the end of the material container. Each time through the for loop we increment by 1, and we then take and delete whatever the current value of the iterator is. After we delete everything inside here, we just call MVP materials and clear to make sure that we're no longer containing those pointers, which are now invalid. The other thing we need to do is implement the save function. And I'm just going to put it right here, right above the delete all materials. So when we call save material, we're passing in a pointer to a material. If this pointer is null, we return an error message and we just return 0. If it isn't null, then we assume that this is a valid material pointer, so we just push it right onto our container that we're going to use to store all of our materials. And then we return an unsigned integer for the size of this current container, which we're going to treat as the ID number, so that when we need this material later on, we can just access it using this ID number. The other thing we need to change is inside clear all, we need to now also call delete all materials. Okay, and that should be it. Let's just try to build this. Oh, we did get a bunch of error messages. Alright, identify material not found. What we need to do here is just near the top here we need to include material.h. We might as well delete this since it didn't seem to cause any problems. And I'll just put it right here. Okay, that's it. Now, in the next video, we're actually going to go and use this material class to change colors and make objects different colors. But before I go and record that video, I want to give you a little bit more description on what kind of parameters we can play around with inside the material. And the best way to do that, for me to demonstrate to you, is to open up VRUM. So let's go ahead and do that. Okay. I'll just create a simple scene here with a box. And I'll rotate this box. Oh, I created two boxes by accident. I'll take this box and I'll rotate it. And I'll rotate it down a bit, just so we have a little bit of shading here. Now, inside the material, we have the exact same parameters. We have diffuse color, emissive color, color specularity, ambient intensity, shininess, and transparency. Okay, let's take a look at these. Diffuse color is the color of the object that is not dependent on the position of your eye. It's just dependent on the position of the light source. So for instance, if I make this object green, I can do so like this, then the diffuse color is set to green, but you'll notice that the shading of the object itself is brighter here and darker up here and so on, and it's only dependent on the light source. Well, where exactly is the light source? Right now, by default in VRealm, the light source is attached to my head, just like a headlight, so it's actually pointing straight ahead. If I turn that guy off, my headlight, you'll notice the object goes completely black because there is no light source now in the scene. Let's go and place a light source in the scene, and then we can discuss what's going on here. Okay, I have placed a point light source, and I'll just move it sort of right in front. It's right now in front of the box, and I'll move it a little bit over to the left, like so. So the light source is somewhere over here, and it's shining mainly on this face. So this one looks like a brighter green. This one is receiving a little bit of light because of the way that the box is oriented, but this one isn't receiving very much. So it's almost looking black, but it does have a green tinge to it. So that's what diffuse color does. It gives you a representation of the color dependent on the angle that the light source comes in and hits the object on. Now let's take a look at, let's say, specular color. Specular color defines the highlights that come off the object. And as a matter of fact, this box is not a very good tool to use to show specular light. Let me just move it over to the back here. And instead, I'll create a sphere that will color the same green color. We can do that. Just copy this material, delete this one, and paint it green. Okay, so we have now a ball here that's same green color as this box. So light source is still over here somewhere. But now let's go and change the specular color. By default it's black, but we can give it some other color. Let's make it blue. And actually we have to give it some sort of intensity and give it blue. You'll notice now that there's a highlight right in the middle here on the ball itself. And you can imagine this kind of like having an apple that's really, really clean and shiny. The specular color is sort of the shininess that comes off of the object. And by default, it's set to black because the object doesn't have any specular highlights. And you notice as I crank this up, there's sort of it's called a hotspot that forms on the object. You can see it's turning white here. And we can control what color that hotspot is. We can make it look blue, make it look pink, whatever. By changing the color of the hotspot, you can sort of give the object itself properties that normally you wouldn't think it has. So for instance, if you had a copper penny, you would expect that the light reflected back from the penny is sort of like a copper tinge, not white. So you'd want to go in here and change it to sort of a copper color. Now, that doesn't look very realistic because the object color itself is still green. So here you should also set it to be something like a copper penny. I don't know, maybe that color there. So now it looks like there's sort of a reddish color coming off of the object wherever the light is hitting it. And the specular highlight is dependent on where I am with respect to the light source. So that's what specular color does. I'm going to go and turn this off now so that it's easier to demonstrate the next guy. Again, diffuse color, I'll make it really dim here. And actually no, I'll put the diffuse color, I'll make it green again, and click OK here. Now remember, if I turn my headlight on and off, I can introduce a second light source. Okay, so we're back to the default state here. We have two objects that are colored, and we have one light source in the scene. I'll turn the light source off, and everything goes black, because there's no light, so everything looks black. Okay. Now what happens when we go in here and we play around with the emissive color? Well, let's go take a look. I'll make this object have an emissive color of kind of blue. So I'm playing with the material properties of the box right now, and I'll make it very subtle, just down here. This is controlling the intensity value, and this is controlling the color. Let's make it kind of blue. So it appears that I just sort of mixed green and a blue together. But watch what happens now. I'm going to go and turn off the light source. Remember, before everything was completely black. Now the box itself appears to be glowing. it has a kind of bluish glow. Well, emissive color is the color that the object gives off even when there's no light sources present. So I can come in here and I can crank this up and make it look like a neon light almost, and no matter what color I set here, that's the color that the object is going to give off. But notice that there's no shading here. The light source is evenly distributed. It's almost like a glow. So it's coming off of every single face, and you can't tell the edges of the box anymore. If I do the same thing with the sphere, it will just look like a complete flat circle. Notice there, it looks like a complete flat circle because we're not getting any visual cues to say what the shading looks like. The shading cues come from diffuse color. So if we turn this guy back on, we now get shading on here. But you have to be careful because you can easily saturate your objects. You can notice now these objects look really bright, and that's because we're mixing diffuse color with specular color. So that's emissive color. We have diffuse color, which is the standard color dependent on the location of the light source, emissive color, which is how much light the object gives off, and specular color is the highlights that the object has. We also have, actually let me turn emissive off. We have ambient intensity. This is how bright the object looks even when there's no light present. So it's kind of like emissive, but it's an overall color, and it's always dependent on the diffuse. So if I crank this up to 1, you'll notice this guy gets brighter. If I go and close this and turn the light off again, you notice the box itself has kind of like a grayish color now because of that ambient parameter here that we're cranking up. So if I lower it, you notice that it's getting brighter or darker or whatnot. So it's similar to emissive, but it's just an intensity. It tells you how bright or dark the diffuse color will be. Shininess controls, let me turn the light back on to show you this. Actually, it's better with the sphere to show you this one. Turn emissive off. Shininess, and let's put some specular highlight on here. Shininess controls how big our hotspot is. So if we have 0.1 here, you notice it's kind of big. If we go to 0.2, it's a little smaller, a little smaller, a little smaller, and so on. All the way up to 1, it's kind of tight, you can imagine. But if we go all the way down to 0, then it just completely washes out the entire surface. So you have to also be very conscious of how much of this parameter you use, because it does saturate your image depending on what value you choose. 0.2 is the default. And then the last value here, we have transparent. We're not going to control transparency the same way VRealm does, so I'm not even going to talk about that. Transparencies for us is going to be controlled using the alpha value. Using the alpha value, we can make the whole object either become invisible or visible, or we can make it transition from partially visible to fully visible. Okay, so those are the parameters we'll be able to play with in the material class, and we'll do that in the next video. So come back then to check out how to implement all this inside of our scene graph.